In this video, let's take a look at finding the partial of this function, e to the negative x, y, z. So this is a function of three variables, and I'm going to find the partial with respect to x. I'm going to put here f with a little subscript of x to indicate it's the partial with respect to x. So here to do it means specifically you're going to use a chain rule essentially. So you just copy this whole thing straight down, so it becomes e to the negative x, y, z. And the only difference after that is you multiply by the derivative of the exponent. The derivative of the exponent with respect to x, that is. Let's work that out on the side here. Let me do that over here. So I'm just differentiating just the exponent part. So it becomes the partial with respect to x of negative x times y times z. When you do this partial, keep this in mind. The y and the z are treated as constants, which means you leave them alone. You just pull them outside like this. And then you have just the partial with respect to x of negative x. When you work that step out, it just becomes yz. Partial with respect to x here is just negative 1. And then it's conventional to put a negative 1 out front, so it gives you negative yz. That's a whole separate step there, so let's see. This would be step 1, step 2, step 3. And now, back at our major step 2 over here, I'm going to say f sub x equals e to the negative xyz times negative yz. In other words, this quantity goes into this position right here. And then it's conventional to write this as f sub x equals, you place the negative yz out in front, so it becomes negative yz, e to the negative xyz, and that is it. Thanks so much for watching. Leave a like. I'll see you in another video.